Hey everybody! Chemistry Cat couldn't be with us today, but he sent his replacement friend. Chemistry making your head hurt? Well, that's because your brain is expanding from all that knowledge that you're gaining. So today we're going to be learning about molecular formulas. Hopefully you've got your notes handy. Molecular formula shows the actual number of atoms of each element that's present in a molecule or a formula unit if you're talking about an ionic compound. So if we are given the empirical formula and we have the mass of the molecule, we can easily get a multiplier and determine what the molecular formula should be. So here's what we are going to do. We're going to take our empirical formula, in this case it is C3H7, and we are going to find or determine, I should say, the molar mass. So I'm going to write down carbon. I have 3 of them. Hydrogen. There are 7 of them. And we're going to look up the atomic mass of carbon on the periodic table. Rounded to one place past the decimal is 12.0. Hydrogen's atomic mass, rounded to one place past the decimal, is 1.0. So 3 times 12.0 is 36.0. 7 times 1.0 is 7.0. And we need to add these two numbers up. So that gives us 43.0. And gram per mole is our unit. And I would like to call this my empirical mass. So this is my empirical mass. So in the first part of the example problem, I'm also given the molecular mass. It is 86.0 grams per mole. So this is what the molecule's mass is. So what I'm going to do now is take this 86.0 divided by my empirical mass. 86.0 divided by 43.0 is 2. And this is my multiplier. So 2 is my multiplier. I'm going to take that multiplier and I'm going to multiply the subscripts by 2. So C3H7 now is going to become C6H14. And that is my molecular formula. So this math is very simple. If you are given the empirical formula, you'll always be given the molecular mass. Now, if you are not given the empirical formula, then you have to determine what it is from the data, just like in yesterday's notes and worksheet. So here's an example like that. Determine the molecular formula for succinic acid, a substance produced by lichens. Those are the things that grow on trees. Analysis shows the compound is composed of 40.68% carbon, 5.08% hydrogen, and 54.24% oxygen. The molar mass of the compound is 118 0.1 grams per mole. So that's my molar mass of my compound that I am interested in figuring out the molecular formula for. So I have three elements, carbon, hydrogen, and oxygen. They are given in percentages. Do you remember what to do when you're given a percent? Change it to grams. So that is going to make 40.68 grams of carbon. We want to convert it to moles, so we're going to multiply by 1 mole carbon divided by the mass of carbon, which is 12.0 from the periodic table. And that comes out to be 3.39. We want to keep 3 significant digits, and we have to now round so that we get 3 significant digits, 3.39 moles of carbon. Okay, so now we're going to take the hydrogen and convert it to moles. I've got 5.08%, change it to gram, hydrogen times 1 mole hydrogen divided by the atomic mass of hydrogen, which is 1.0 grams. And this comes out to be 5.08 mole of hydrogen. Now finally we're going to do the oxygen. 54.24 instead of percent, put gram. Oxygen times 1 mole oxygen divided by the mass, atomic mass of oxygen, which is 16.0 grams mole, equals 3.39 mole oxygen. Now, do you remember what we need to do once we have these answers? We look for the smallest answer. And it turns out to be 3.39. And we are now going to divide each of these by 3.39. That'll give us a 1. So we have 1 atom, or I should say 1 carbon atom. Take the next answer, divide it by 3.39. Oh, it comes out to be 1.5. We'll come back to that in a moment. Our last one, we divide by 3.39, which equals 1. Well, what do I need to do? I've got a 1, a 1.5, and a 1. And these need to be in whole number ratios. So what I'm going to have to do is multiply by 2. Okay, so I'm going to double all of these answers. Times 2 gives me 2 carbon atoms times 2 gives me 3 hydrogen atoms times 2 equals 2 oxygen atoms. So I've just now figured out what my empirical formula is. I've got 2 carbon, 3 hydrogen, and 2 oxygen. And the sequence that they are going to go in is going to be like how you encountered it in the example data. So the carbon came first, then it was the hydrogen, and then the oxygen, and that's the order that they're going to go in. C2, H3, O2. So here's my empirical formula. So this is pretty much where we are with the last example problem. We had the empirical formula and we had the molar mass of the molecule. So we're just going to figure out what the empirical mass is. And I've got carbon, there's two of them, times 12.0, which is the atomic mass. That gives me 24.0. I have three hydrogens, times 1.0, which is the mass of a hydrogen atom. Gives me 3.0. And finally, oxygen. Two of those times 16.0 equals 32.0. Okay, so what we need to do now is add these all up. It comes out to be 59.0. Okay, so that's my total. And this would be my empirical mass. If we come back up to our molar mass of our compound, it's 118.1. And so we are going to take the 118.1 divided by 59.0. And we get a multiplier of 2. Now, it's not always going to be a 2. It could be a 3, a 4, a 5, a 6. Okay, so there is my multiplier. Now, what do I need to do with the multiplier? I come back up here to my empirical formula and I multiply each of the subscripts by that multiplier. So these all get multiplied by 2. So times 2 times 2 times 2, and the 2 now is going to become a 4, the 3 becomes a 6, and this 2 up here becomes a 4. So my molecular formula, C4H6O4. That's what I'm after. There's my my molecular formula. All right, so you have a worksheet to complete. Don't forget to copy the notes down and submit those as well so you get your points for your notebook.